Welcome to my presentation. In this presentation, we shall see how to effectively solve system of linear equations using matrix methods. So if we have system of linear equations of the form, let me write this one here. If we have a matrix like this, A11 x1 plus A12 x2 plus A13 x3 is equal to B1, and if we call this as equation number 1, and if the second equation is A21 x1 plus A22 x2 plus A23 x3 is equal to B2, that is equation 2, and the third equation A31 x1 plus A32 x2, let me write this a little bit more clear here, A32 x2, still not clear, so this should be A32 x2 plus A33 x3 is equal to B3. Let's say we have system of linear equations of this form, where A11 is the coefficient of x1, A12 is the coefficient of x2, A13 is the coefficient of x3, and so on. Then we can represent this in a matrix equation of the form. We can write this one of the form A times x is equal to B. We can write it in this format. How can we do that? Let me write that here. If we were to take the coefficients of x1, x2, and x3 and write it out as a matrix, that is called the coefficient matrix. We have seen that when we were talking about matrices in my earlier presentations. So if we were to put all the coefficient terms together, A11, A12, A13, A21, A22, A23, and then A31, A32, A33, that is the matrix A, and the variable terms here are x1, x2, and x3, and then the constant terms are B1, B2, and B3. We can represent the system of linear equations in this format, A times x equals to B, and if we were to represent A could be represented as a coefficient matrix, x can be represented as a column matrix like that, and then the constant numbers on the other side of the equal to sign can be represented as a constant matrix or a column matrix, column constant matrix like that. So in here, A is the coefficient matrix, x is the unknown variables where we want to go find that, and B is the constant terms. So in my next presentation, we shall see several examples of solving system of linear equations using these methods.